Okay, welcome. In this demo session, we're going to be looking at the QueuedTask. It's used with synchronous and asynchronous methods. Okay, so I got a project and I have this tab, Async Demo, with my demo samples I'll be working on in this session. And then the first is something called Select and Zoom, which is just going to launch us straight into Visual Studio and into my implementation of the on-click handler. I have a couple of methods, a couple of synchronous methods, one to do a select and then the other to zoom to the extent of whatever is selected. And when I execute that, probably familiar with if you work with a Pro API is this exception here, this called on wrong thread exception. And I'm getting the called on wrong thread exception because I'm calling the synchronous method from the UI thread. So I'm going to stop the debugger and I need to fix this. And so really the whole point about having that exception and this requirement of running on the background is so that you do your GIS work on this special background thread of Pro, allowing the UI to remain responsive. How do I run it on the background thread? Well, I use this construct called QueuedTask.Run, and I just place the synchronous method inside the lambda of the QueuedTask.Run. And QueuedTask.Run has a very similar semantic to the Microsoft system.task.run, even though it is actually a completely different thread. But it's designed to look and feel the same. So there we go. I now have my synchronous methods wrapped in a QueuedTask.Run, so they'll run on the background. That's great. The last thing I'm going to do is I'm going to await the execution of the first one. So I'm going to do a non-blocking wait for select features to finish executing completely before going on to executing a zoom to selected. And when I use the keyword await, I have to pair it with an async modifier added to the declaration of the containing function. I'll rebuild. Also in the code, you may have noticed I have a little check here for the viewing mode of the active map view. If the active map view is not a 2D map, I pop a message box. All right. So although this code, it's technically correct, the purpose of the Synchronous API really isn't so much to force you to run each synchronous method within its own queue task. So in that regard, this code, kind of misses the point. The reason for the predominantly synchronous API is because in most cases, when your workflows, your custom workflows themselves are synchronous. And typically, you combine a sequence of synchronous methods together into one complete workflow. And then it's the workflow itself in its entirety that you run asynchronously. And so really, that's what I want to do here. Even though my workflow is just 2 steps, the selection followed by the zoom, the real intent here is that you combine your synchronous methods together that comprise your workflow, and then they're run within the context of a single queue task, like so. There's another change I want to make here, and it's the use of this mapView.active within the queue task. So after I've extracted the extent from the map view, this line here, I invoke the QueuedTask.Run, which I'm awaiting, and so control returns to the UI. So it's conceivable, though unlikely, but it's still conceivable, that during the time between the invocation of the queue task, and its await, and then the execution of the select features, that the active view in the application could change. After all, the UI remains responsive, so an attribute pane, a layout pane, or whatever, could actually become the active view, in which case mapView.active would be null. And so in order to preserve the state of the map view so that it is consistent between its state in the UI and then its state when I actually get a hold of it inside the QueuedTask.Run, I want to capture that state that I want into a local variable. And in this particular case, it's the mapView.active I want. So I'm going to capture it into a local variable at the top of my method, like so. And I'll just add in a null check as well. Okay, so I've captured the state of the mapView.active, and then I use that captured state inside my QueuedTask. So whatever the user does to the UI, invokes a layout, attribute pane, or whatever, my state is consistent here when I get inside the QueuedTask because I captured it in the local variable MV. For consistency's sake, I'm just going to change all uses of the mapView.active to use my local variable MV. Of course, that's not required, as the state of mapView.active isn't going to change inside the context of the on-click on the UI. It's only going to change conceivably, an edge case, between the UI and the invocation of the QueuedTask.Run. And so there is my final implementation. Okay, back to my async demo tab, select and zoom. Now I'm executing the select features using my local variable that's captured the active map view state when the on-click was clicked. And of course, in the 3D flavor, I still have my check and message box. All right. So when your workflows are particularly useful, it's natural to want to consolidate them into helper or utility methods. Something very common in ArcObjects. ProSDK is the same in that regard. So I'm going to take my workflow here. And I'm going to go to this little helper class I've got stubbed out called map helper. And here I've got the beginnings of something I've called select with extent. I've added some parameters for the map view and then the extent options. And I'm just going to paste in the code like so. This is going to be a synchronous method. Okay. So here is, a map view parameter, the select and the zoom. And I've added an int return because I want to return the number of features selected. So let me just implement that. I'll return the selection from the select features, and then I'll just return the count. And I just get the count from summing up all of the object IDs selected from the features, like so. Okay, so there is my total number of features selected. Great. So here is my initial cut of asynchronous helper method for use with ArcGIS Pro. I'm going to go back to my select and zoom. Okay, once again, I need the QueuedTask. Only this time, I'm going to execute my helper method, map helper, and then I call it select with extent. And then I pass in the map view. I pass in the delta for the extent, and then, my flag, like so. I'm returning the number of features selected. So the way I just return something in a QueuedTask is I just add the return statement. I await the QueuedTask, and then I can just simply assign whatever is returned from the QueuedTask into, in this case, a local variable I've called numCell. And I'm just going to pop up a message box showing the number of features selected. Okay. So there we go. We've just changed the onClick handler to use now our custom helper method. All right, so back in Pro, async with demo tab, selecting zoom. Now I'm invoking my helper method inside the QueuedTask.Run, which I'm awaiting, same as before. And now I'm just returning the number of features selected. Here's my zoom, there's my message box, 881 features selected. And on the map 3D, select and zoom. Once again, executing my helper. Only this time we're popping up our map view must be 2D message. Okay. No features selected. All right. So here is our synchronous method. And one thing I'm definitely not happy about is the use of this message box.show. So this really should be avoided, showing any kind of modal UI when you're within the context of the queued task. So when I show that modal UI, essentially the queued task is stuffed for all uses of the application until the user acknowledges that modal UI, the message box in this case, and closes it so execution can continue. So I need to remove this message box. All right, well, if I remove the message box, what am I going to replace it with? Well, that really depends on your own coding conventions and whatnot. Some people use flags. So, for example, instead of returning 0, I return, a special code, perhaps -1, indicating that rather than nothing being selected, there was something wrong in the execution of the function. Me, myself, I prefer to throw an exception. So if the map view is not a 2D map, I'm going to throw an exception. I'll throw an argument exception, and I'll just use the message that I originally had in the message box as the exception message. Okay, so there we go, like so. I'll go back to my button. Now, of course, select with extent throws an exception, which it didn't do before. Okay, so I want to add some exception handling then. One thing I can do to catch the exception is I can simply add my exception handler inside the QueuedTask.Run. And I just have it ready in my paste buffer. Just paste it in like that. And then, I'll just add the map helper, select with extent. I'd add it inside here, like so. I'd return the value from select with extent. In this case, the problem with this is that, well, I still got the problem of the argument exception, and then if I want to show a message box, well, I'm still inside the QueuedTask.Run. But essentially, within the QueuedTask.Run, try-catch works just the same as if you were on the UI. Well, actually, what I really want to do is I want to add my try-catch around the queued task itself. And then in this case, I can just put my entire queued task statement inside the try. And then in my argument exception, I am just going to show the exception message. Now this works because I am awaiting the queued task. So that's the key. The simplest way to deal with exceptions is to put the try-catch around the queued task and await it. If you do not await the queued task, what happens is execution returns immediately from the queued task invocation. Select with extent, of course, keeps on running. But by the time that select with extent has completed or hits the exception, your code back in the UI, in the onClick, has exited the scope of the try-catch. And so it's actually sort of down here or wherever. And when that exception is thrown, it's not caught. and it will crash the app. Build and run. Okay, back to Pro, my async demo tab, select and zoom. Same as before, 881 selected. I go to my 3D tab, select and zoom. Okay, so there's our argument exception in our synchronous function. Instead of our message box, we throw our exception. Map view must be 2D. Okay, and we catch it outside of the queued task, which we're awaiting, and then I show the message. Okay, map view must be 2D. Okay. So let's say that the select with extent, it's a useful enough function that I want to provide an asynchronous equivalent that can be called standalone. The way I go about doing that is like so. I take the declaration of the synchronous method, just really duplicate it. We add that async suffix convention, and then I need to change the return type from int to be a task of int. So I simply change the return type to be wrapped in a task. If it's void, if it doesn't have a return, simply return task. And then whatever is the synchronous method, wrap it in a return QueuedTask.Run. It's always return because at the minimum, you're going to return the task to the caller. And then within the QueuedTask.Run, simply call your synchronous method. I'll just hit carriage return here so you can see the arguments. So mv dot select with extent. There's my synchronous method. I converted it to an extension method. That's why I can call it directly off the map view. And then I just pass through the parameters from the asynchronous method to the synchronous equivalent. And of course, this returns the number of features selected. So I need a return statement. If it's returning void, you do not need the return statement. So there is my asynchronous wrapper selected with extent async, providing the asynchronous alternative to select with extent. I go back to my select and zoom, and now I'm going to use my asynchronous equivalent like so. I'm just calling it standalone. It's an asynchronous method. I can call it directly from the UI. No need to use QueuedTask. The whole QueuedTask is implemented internally. Build and run. So back to my async demo tab, select and zoom. I'm calling my asynchronous wrapper now, my asynchronous method. I'm calling it directly from the user interface thread. It invokes the QueuedTask internally. I do the selection, the zoom selection, show number of features selected. Now let's move on to talk about our final topic, which is cancellation. So let's go back to the map helper. And what I have done here is I have added a new synchronous method called select and process features. It essentially has the same argument parameters as did our select with extent, only I have added an additional parameter called a cancelable progressor source. Okay, and that's a little basically it's a progressor dialog that will show up. It has a little progress bar, status message, and if you want to support cancellation, the user can click that cancel button and then convey that cancellation status down to your add-in. Here's my progressor source. So this is the progressor bit. You set a max value, which will be essentially the number of steps that your progress bar will have. A starting value, in my case 0. Optionally, you can update a status message. In this case, every time I loop on a feature layer, I show its name. And then I increment or step the progressor. I'm not really doing anything in the process. I've got a task.delay. That's just a stock function, which is doing a 2-second delay on every feature layer loop. I check the token within the cancellation token source on that progressor. If it has been canceled, this is cancellation requested flag, I return false. Okay, and same as I did in the previous part of the demo, take select and process features, copy paste it, async, return type of bool, I've wrapped it in task, same parameter list, except I have added the cancelable progressor source, likewise gets passed into my synchronous function. Let's just go to our button click handler, which I've called select with cancel, and I've got it stubbed out here. Okay, so we are going to call that extension method on the map view, which I called select and process features async. It takes the same parameters as before, a delta for the extent, a flag as to whether you apply that as a ratio or not, and a progressor source. Now, the requirement for a progressor source is it has to be constructed on the UI thread. So I go progressor source, and I want a cancelable progressor source. So cancelable progressor source, and then I'm going to just show, my regular message, which is, processing features, and then an optional message to show on the cancellation. I'm just going to say cancel process. And then I pass the progressor source, cancelable progressor source, as the final argument of my asynchronous method. So here is our asynchronous wrapper, select and process features async, the cancelable progressor source. All right, so to get the progressor to show, we pass the progressor component inside the progressor source to the QueuedTask.Run. And of course, we pass the cancelable progressor source through to our synchronous method. Okay. All right. And the QueuedTask.Run will take care of showing it at runtime. Now, one little idiosyncrasy, progressors will not show when we're in the debugger. So to actually see this, you have to run it outside of the debugger. You can't actually step through and see the cancelable progressor at the same time as you're debugging. All right, so I'm just going to start Pro actually from the outside of the debug. All right, let's go back to my async demo tab, and so here's my select with cancel, right? There's our cancel button, I'll cancel. There's my cancel message, cancel process, and I terminate execution. I have a finally block doing the clear select. Okay, and the QueuedTask, it takes care of showing that progressor for us. Okay, so currently, if cancellation is requested, I'm returning false. Instead, what I can do is, on the token, is a special method called throw if cancellation is requested. Throw if cancellation is requested. And that means that if cancellation has been requested on the token, then just throw an exception. So I don't even need this if check either. I can just go straight to the token. If I've been canceled, throw this exception. Task.delay, I don't have access to the internals of task.delay, so what I'll do is I'll catch the exception it throws as before, and then if it's throwing that task canceled exception, well, I'll call the throw of cancellation is requested on the token, same as I'm doing directly here, but this will be what you're doing in your code, okay? All right, so then in the caller, which is our select with cancel, we have to catch that exception. So I need to add to this a catch, and then the task will throw something called an operation canceled exception. And I know if I get the operation canceled exception that I have been canceled. And I'll just pop another message box. Like so. Okay, let me compile this. Again, I can't run it in the debugger. I have to run it from the taskbar because otherwise the progressor won't show. Okay, async demo tab. So now we're just going to do the same thing, but we're going to throw that exception. So here we go. I do the select with cancel. I cancel. Okay. It threw the exception. That's my custom canceled message where I'm capturing that operation canceled exception. All right, so that concludes our session. I do have one other example showing the use of a cancellation token source directly. I'll make that available in the code sample for the session, and you'll find that under our Dev Summit resources on our ArcGIS Pro SDK wiki. And I hope the session has been helpful. Thank you for your time.